On July 4th, 2016, while most of America was grilling burgers and waiting for fireworks, a spacecraft the size of a basketball court was flying blind into the most dangerous radiation field in the solar system. It was approaching Jupiter at 130,000 miles per hour, one of the fastest speeds any machine built by humans had ever reached. And in the next 35 minutes, it had to perform a single engine burn with absolutely no help from Earth. A radio signal from Jupiter takes 48 minutes to reach us, which means that by the time Mission Control saw anything at all, whatever was going to happen would have already happened. If the burn worked, the spacecraft would be captured into orbit around the largest planet in the solar system. If it failed, a billion-dollar machine and 15 years of work would sail past Jupiter into the darkness, forever. So the team at NASA's Jet Propulsion Laboratory did the only thing they could do on that holiday evening, which was to sit at their consoles and listen for a series of simple radio tones, like heartbeats from across the solar system. This is the story of how humanity dove beneath the clouds of the King of Planets again and again for 10 years, and what we found down there. Most people assume Jupiter is dangerous because of its size, or its storms, or the crushing pressure inside it. And all of that is true, but none of it is the real problem. The real problem is invisible. Jupiter has the most powerful magnetic field of any planet in the solar system, roughly 20,000 times stronger than Earth's. And that field does something monstrous. It grabs charged particles, mostly electrons, and whips them around the planet at close to the speed of light, concentrating them into gigantic invisible belts of radiation that wrap around Jupiter like a death zone. Heidi Becker, who led Juno's radiation monitoring team, described these belts as the scariest place NASA has ever sent a spacecraft after the Sun itself. A region where particles hit like bullets fired from every direction at once. Over the course of the mission, Juno was expected to absorb a radiation dose equivalent to about 100 million dental X-rays. Unprotected electronics in that environment do not degrade gracefully over years. They scramble and die within weeks. And yet, the scientific prize on the other side of those belts was enormous. Because Jupiter is not just another planet. It was the first planet to form. It swallowed most of the leftover material of the early solar system, and its deep interior is a preserved record of how our entire planetary system came to exist. Scott Bolton, the mission's principal investigator, calls Jupiter the Rosetta Stone of the solar system. And there was only one way to read it, which was to get closer to it than anyone had ever dared. Before we get to the machine itself, there is a detail about this mission that most people miss, hiding in plain sight in its name. NASA missions usually get acronyms, clumsy stacks of technical words squeezed into something pronounceable. But this spacecraft was named after a goddess. In Roman mythology, the god Jupiter drew a veil of clouds around himself to hide his mischief from the world, and only his wife, the goddess Juno, had the power to look straight through those clouds and see his true nature. That is not just poetry, it is literally the mission description, because the entire purpose of this spacecraft was to see through Jupiter's clouds for the first time in history. The mission was proposed in 2003 by Scott Bolton and his team, and it launched from Florida on August 5, 2011, beginning a 5-year, 1.7 billion-mile journey that included a slingshot flyby of Earth in 2013 to steal some of our planet's orbital energy. And riding on board, bolted to the spacecraft, were 3 small Lego figurines made of spaceflight-grade aluminum, one of Jupiter, one of Juno holding a magnifying glass, and one of Galileo, the man who first pointed a telescope at this planet 4 centuries ago. Somewhere in orbit around Jupiter right now, there are 3 Lego figures that have traveled farther than any toys in human history. Now here's the engineering problem that had to be solved. You cannot shield an entire spacecraft from Jupiter's radiation, because the amount of metal required would be far too heavy to launch. So the engineers made a decision that sounds almost medieval. They built a vault. At the heart of Juno sits a titanium box with walls about 1/3 of an inch thick, weighing roughly 400 pounds. And inside that box lives essentially the entire brain of the spacecraft. The flight computer, the power systems, the most vulnerable electronics of every instrument. NASA effectively built a bank vault and flew it to Jupiter. The second problem was power, because Jupiter is 5 times farther from the Sun than Earth is, which means sunlight out there is 25 times weaker, and no solar-powered spacecraft had ever operated at that distance. Juno's answer was brute surface area. 3 enormous solar wings spanning 66 feet from tip to tip, the size of a basketball court, which generate a comfortable 14 kilowatts near Earth, but only about 500 watts at Jupiter. Think about that for a second, because it means one of the most sophisticated machines humanity has ever built runs on less electricity than a hairdryer. But the real genius of Juno is not the vault or the wings, it is the orbit. Instead of trying to survive inside the radiation belts, Juno was placed on a wildly stretched polar orbit that threads a narrow gap between the inner edge of the belts and the top of Jupiter's atmosphere, diving in over the North Pole, skimming just a few thousand miles above the clouds, and escaping out past the South Pole before the worst of the radiation can catch it. The spacecraft does not outmuscle the death zone. It slips through a keyhole in it, over and over again. Which brings us back to that 4th of July evening in 2016. To be captured by Jupiter's gravity, Juno had to slow itself down by firing its main engine for 35 minutes. And it had to do this while crossing the radiation belts for the very first time, with its main antenna pointed away from Earth, running entirely on autopilot. The spacecraft spun itself up like a gyroscope for stability and committed to the burn. In the mission control room in California, there was nothing on the screens but a sequence of simple tones, each one a coded heartbeat, confirming that another step had completed, each one already 48 minutes old by the time it arrived. Engineers who had spent over a decade on this machine stood in silence and listened to their spacecraft report its own survival from 500 million miles away. And then, at 8:53 p.m. Pacific time, the tone they were waiting for came through, confirming the burn was complete and the orbit was captured. And the room erupted on a night when the rest of the country was already celebrating something else. Juno was in orbit around the largest planet in the solar system, and the diving could begin. What Juno found under the clouds rewrote the textbooks, chapter by chapter. The spacecraft carries a microwave radiometer that works like an X-ray machine for a gas giant, peering hundreds of miles below the visible cloud tops, and one of its first targets was the most famous storm in the solar system. The Great Red Spot, a hurricane wide enough to swallow the entire Earth, turned out not to be a thin painted feature on the clouds, but a monster with roots plunging at least 200 miles into the planet, far deeper than anyone predicted. The powerful jet streams that stripe Jupiter's face reach down roughly 1,800 miles, meaning the weather we see is only the surface of a weather engine thousands of miles thick. At the poles, Juno photographed something no one had ever imagined: entire clusters of cyclones locked in geometric patterns. 8 storms arranged around the North Pole and 5 around the South, each cyclone the size of a continent, holding formation year after year, like planets in a dance that physics is still struggling to fully explain. High in the clouds, where it is far too cold for ordinary thunderstorms, Juno caught flashes of shallow lightning, and the best explanation involves something wonderfully strange: slushy hailstones of ammonia and water that scientists call mushballs, forming high in the atmosphere and raining down into the depths. The magnetic field turned out to be lopsided and alive, including a concentrated patch of intense magnetism near the equator that researchers nicknamed the Great Blue Spot. And deepest of all, Juno's gravity measurements revealed that Jupiter's core is not a neat, solid ball, but something fuzzy and diluted, heavy elements smeared through the inner half of the planet. And one leading explanation is astonishing: that billions of years ago, a young planet roughly 10 times the mass of Earth slammed head-on into Jupiter and dissolved into it. The king of planets may be a body with another world buried inside it. Then the mission did something almost no one expected, because its orbit slowly evolved, and the team turned that evolution into a second mission, for free. Each time Juno's path drifted close to one of Jupiter's giant moons, the engineers used the encounter like a gravitational gear shift, bending the orbit tighter while grabbing science no one had planned. In June of 2021, Juno flew past Ganymede, the largest moon in the solar system, humanity's first close look at it in more than 20 years. In September of 2022, it skimmed the ice of Europa, photographing the fractured shell that hides a global ocean, scouting the ground for the Europa Clipper mission that is on its way there right now. And at the end of 2023 and the beginning of 2024, Juno did the most dangerous thing of its entire career, flying within 930 miles of Io, the most volcanic world in the solar system, closer than any spacecraft in 22 years. The images show a nightmare landscape, in the best possible sense. Hundreds of volcanoes, plumes rising into space, and lakes of molten lava glowing in the darkness like open wounds. With each moon encounter, Juno's orbit around Jupiter shrank, from 53 days to 43 to 38 to 33, which meant the spacecraft was diving through the radiation keyhole more and more often, and the radiation was quietly keeping score. By 2023, Jupiter was winning. JunoCam, the spacecraft's public camera, the one whose raw images are processed by an army of volunteer citizen scientists around the world, began to fail, its pictures dissolving into streaks and noise as accumulated radiation damage ate away at a voltage regulator. There is no repair shop 500 million miles from Earth, so the engineers reached for an idea that sounds like folk medicine, a process called annealing. They deliberately overheated the dying camera, baking it with its own internal heater, because at higher temperatures, the damaged silicon can partially heal itself, its crystal structure relaxing back toward health. It was a gamble, and for days the images stayed broken. And then, just in time for the closest Io flyby, the pictures cleared, and the before and after frames published by the engineering team look like a miracle in 2 panels. Juno had survived launch, 5 years of deep space, an engine scare, a decade of radiation, and its own aging body. What nearly killed it, in the end, was none of those things. On September 30th, 2025, Juno's mission extension officially expired, on the exact same day the United States government shut down. And in the proposed budget for 2026, the mission's funding had been zeroed out entirely. For weeks, NASA could not even publicly confirm whether the spacecraft was alive, and headlines around the world quietly began writing Juno's obituary, a functioning, healthy explorer possibly switched off by paperwork while orbiting another planet. And then spring came, and Juno answered the question itself. Because on May 1st, 2026, it flew within 3,100 miles of a tiny inner moon called Thebe, and sent home the sharpest images of it ever taken. The machine had outlived its own obituaries. Shortly afterward, the mission's instruments were powered down for good, and the final view ever taken by JunoCam now sits quietly in NASA's public gallery, the last frame of a 10-year film. The spacecraft that defeated the worst radiation in the solar system was finally stopped by a line in a spreadsheet. Here's what happens next, and it was designed this way from the very beginning. Juno is now a silent passenger on a decaying orbit, and over time, Jupiter's gravity will drag it down into the very clouds it spent a decade photographing, where it will streak across the sky as a meteor and dissolve into the atmosphere of the planet it studied. that ending is not an accident. It is planetary protection, a guarantee written into the mission's design that this spacecraft can never accidentally crash into Europa and contaminate an ocean where life might exist. Even in death, Juno is guarding the most promising world in the outer solar system. And its inheritance is already flying, because the radiation maps Juno drew from inside the death zone are built directly into the armor of Europa Clipper, arriving in 2030, and Europe's Juice spacecraft arriving in 2031, both of which will survive Jupiter because Juno measured exactly what Jupiter does to a machine. Everything we learned about how giant planets form now travels with us to other stars, because most of the worlds we discover in the galaxy are Jupiter's cousins, and for the first time, we understand one of them from the inside. For thousands of years, the brightest wandering light in the night sky was a god, an omen, a king to be feared from a distance. Then, for 10 years, a spinning machine with a titanium heart and the power budget of a hairdryer stared that king directly in the face, dove beneath his clouds 76 times, and told us what he was hiding. If you found this story worth your time, hitting the like button genuinely helps YouTube show it to more people who would appreciate it. And subscribe if you want to be here for the next one. Because next time, we are going to talk about a black hole that was just caught setting off the most powerful stellar explosion ever recorded. An event so strange that astronomers named it after a dog.